Hello future pilots, let's start the fourth chapter of instrumentation, which is the vertical speed indicator. The vertical speed indicator or the VSI main function is to indicate the rate of climb or descent by measuring how fast atmospheric pressure changes with altitude. So, the function of the vertical speed indicator is to indicate the rate at which the aircraft is climbing or the rate at which the aircraft is descending. And how can we see it? If we look at the instrument and we look at the needle, if the needle is at 0, that means that the aircraft is not climbing nor descending. But if the needle is at 5, up 5, that means that the aircraft is climbing at a rate of 500 feet per minute. And if the needle is at down 5, that means that the aircraft is descending at a rate of 500 feet per minute. Alright, but how does this work? So it works by measuring how fast atmospheric pressure changes with altitude. So if we measure the rate of change of static pressure with altitude, the VSI will indicate the rate of climb and descent. Next, how does this helps the pilot? So it helps pilot maintain desired altitude transitions, stabilize level flights and control approach or climb gradients during critical phases like takeoff and landing. So if the pilot wants to maintain a desired altitude, for example 5000 feet, so the pilot will look at the instrument, and if the needle is showing 0, that means that not the aircraft is climbing and not descending. So the aircraft is maintaining a level flight. And for example, if the aircraft is at finals and the pilot wants to have a steady descent, which is 400 feet per minute. So the pilot will look at the instrument and the needle, which should be pointing at 4, that means it is descending at a rate of 400 feet per minute. Alright, next we want to study about the principle. But before that, I am going to explain you the every parts of the vertical speed indicator. So first is this. So this is the instrument case, or we can say the airtight case. And this is the capsule which expands or contracts. And from here static pressure is fed. Static pressure is the ambient pressure is fed. And the static pressure is fed to both the instrument casing and the capsule. But there is a difference. Let's read this, I will explain you that time. In a level flight, the pressure inside the case and the capsule is same. But during climb or descent, the static pressure fed to the capsule reacts immediately. But the pressure in the casing changes slowly due to a restrictive choke. So what this is saying is that when the aircraft is at level flight, the pressure in the instrument casing and the pressure at the capsule is same. But what happens when the aircraft is climbing or descending? So there will be change in the static pressure. So if there is a change in the static pressure, there will be an immediate change of pressure at the capsule. But the rate of change of pressure in the casing will be at a slower rate. But why is that? It is due to this restrictive choke or this metering unit. Alright, so this is the principle of vertical speed indicator. Next we're gonna understand the construction of the vertical speed indicator. So I will explain when the aircraft climbs, what happens to the instrument and how the VSI indicates a rate of climb. So let's understand that when the aircraft is climbing, what happens? When the aircraft climbs, the static pressure decreases, and we know that the static pressure inside the capsule changes faster than the pressure inside the case. As we climb, the case has a higher pressure compared with the capsule, which causes the capsule to compress. And as connected with the linkage, it rotates the needle, showing indication of climb. So let me explain you. So now we know that whenever there is a pressure change, like when the aircraft climbs or descends, the capsule reacts immediately. There is a change of pressure at the capsule immediate. But there is a slow change of pressure at the instrument case due to this restrictive choke or metering unit. So when the aircraft climbs, what happens? Static pressure decreases. So the static pressure decreases immediately at the capsule, and thus we can say that comparatively the pressure is lower at the capsule compared to the casing because of this metering unit or the choke. So let's write this. Pressure is lower at the capsule and a comparatively high pressure at the casing. So what this led to is that this capsule now compressed because of the pressure difference. And as the capsule compresses, what happens is the linkage moves like this. So if this moves backwards, this rotates like this, and the needle will now rotate in an anti-clockwise, indicating a rate of climb. Alright, so this is how vertical speed indicator works when the aircraft is climbing. Now I will explain you when the aircraft is descending what happens. So when the aircraft is descending, that means the static pressure is now increasing. And if the static pressure increases, what will happen? So the pressure change will be immediate at the capsule, we know. So there will be an high pressure at the capsule. But there won't be an immediate change in the pressure in the casing because of this restrictive choke. So we can say that the pressure at the capsule is comparatively higher than the pressure at the case. So let's write this. Pressure high at capsule and low pressure, comparatively low pressure at the casing. So what will this lead to? So this will lead to a expansion of the capsule. And how will the linkages work now? So this will move like this will rotate like this, and the needle will rotate clockwise, indicating a rate of descent, indicating the rate of descent. Now we learned that when the aircraft climbs or descends, what happens? But what happens when the aircraft levels? The static pressure inside the case equalizes with the pressure inside the capsule, and thus the capsule comes back to its original shape and the needle comes back to zero. So let me explain you. So when the aircraft levels, there will be no change in the static pressure, and we know that there is an immediate change in the capsule, but that doesn't mean that the pressure will not be equal in the casing. Slowly it will also equalize with the pressure in the capsule. So when the aircraft levels, what happens is slowly the pressure at the case equalizes with the pressure at the capsule, and this will make the capsule change to its original size, and the needle will now rotate back to zero, indicating no rate of climb and no rate of descent. Alright, next we're gonna study about the errors of vertical speed indicator. The first error is instrument error. So instrument error, we can say it is the manufacturing defects or the manufacturing imperfections which causes this error. Next is the position error. Vertical speed indicator indicates wrong climb or descent as speed suddenly changed. Most common during takeoff acceleration. So what happens is that when an aircraft starts to move, the static pressure sensed at the static vents becomes low because of the suction effect. So this will cause a fake indication of climb or descent because of the suction effect, and this error is called the position error. Next error is the maneuver induced error. So fluctuation of pressure near static vents during altitude change, the instrument indicates false rate of climb and descent and also causes delay in the indication during maneuvers. So let me explain you what is maneuver induced error. So due to the attitude change of the aircraft, when the aircraft changes in the angle of attack, so what happens is there's a fluctuation of pressure near the vicinity of the static vents. So if there's a fluctuation of pressure, the static pressure will be sensed either higher or lower. So this will cause the VSI to indicate a false rate of climb or descent. Now we're going to study the most important lag, the most important error of VSI, which is the time lag. The pointer takes a few seconds to steady. Because of the time taken to build up at a steady pressure difference on climb or descent, there will also be a time lag on leveling out because of the time taken for the pressures to equalize. This error is most noticeable after a prolonged climb or descent, especially at a high rate. So let me explain you what happens. So we know that the pressure changes at the capsule immediately, but the pressure change in the casing is slow. And when the aircraft levels, what happens is it slowly equalizes with the pressure in the capsule, and thus this time lag is causes this error. So the indication will be also late. So if the aircraft has already leveled out at 4000 feet, but the VSI will be still showing a indication of climb for some seconds. Alright, so this error is most noticeable after a prolonged climb, means that when the aircraft is climbing or descending for a longer time and a very high rate. Alright, so to overcome this error, what was introduced? The IVSI was introduced, which is the instantaneous vertical speed indicator. But what difference does instantaneous vertical speed indicator has that overcomes this time lag? So let me explain you by this structure. So this has an additional, it incorporates an accelerometer unit which respond quickly to a change of altitude. So it is very sensitive. This accelerometer unit is very sensitive to altitude change, and thus whenever there is an altitude change, this dashpot acceleration pump, it rises up or it descends. Alright, and then it causes the capsule to expand and contract, and immediately the needle shows the indication of climb or descent. But there is an error in the IVSI, which is due to the sensitivity of the dashboard, the instrument tends to overreact to turbulent flying conditions, and small fluctuations should be ignored. So what happens is this accelerometer unit is so sensitive that even if there is a turbulence, okay, so what will this turbulence cause? It will change a fluctuation of pressure, or there will be a slight climb or descent in turbulence, right? So the VSI will still show still show the indication of climb and descent, which is not necessary because it is due to the turbulence and not by the aircraft. Thus, next we're gonna study about is the blockages. So what will happen if the static vent only becomes blocked? So if the static becomes blocked, there will be no change in the pressure in the capsule nor in the casing. So the pressure at the capsule and the casing will be equal, and thus the needle will be at zero only, and thus there will no indication, right? So any blockages of the static line or vent will cause the needle to return to zero. So here's the end of the chapter. If you want to get these notes, you can get it from the description, and thank you for watching.